Now we look at the MADI method. Again, we start the problem using the minimum cost method to set up our initial feasible solution. And we use the MADI method to do steps 3 through 6. So we'll have to do a two-step process with the MADI. First, we calculate what's called the row and column indices. U for the row, V for the column. We use the formula C equals U plus V. C is just the transportation, per unit transportation cost that we've been using all along. Once we have the indices for each column and row, we can calculate or evaluate the unoccupied cells. With using the formula listed below, we calculate the indices. You notice I started in the upper left-hand corner. For our indices, the first row, that indice, in this case U sub r, is always equal to 0. So I could use that to get myself started. I take the formula, C equals U plus V. I have, of course, the transportation cost is 4, so, and the indice is 0, so 4 equals 0 plus V, so my V sub A equals 4. Okay, so once I have my indice for V sub A, you notice that I also have an occupied cell and conquered to A. So now I have two pieces of the puzzle there, so I can figure out that indice next. I can figure out U sub C. Again, C equals U plus V. I know my transportation cost is 8. I know my V sub A is 4. So simple 8 minus 4 equals 4. So my U sub C is 4. Now you see that I can use my U sub C to figure out my indice for B, and I'll do that. I've gone through and I've done for conquered to big budget or B. From there I can figure out the indice for V sub B, which is 12. That allows me to, next I can calculate the indice for Winooski, and I'll do that next. Again, I did the Winooski to big budget. From there, I was able to do the Winooski to the comfy, and now I have all of my indices. Okay, I've gone through and calculated the cell evaluations for the unoccupied cells. Again, it's just the transportation costs minus the indices for both the column and the row. You could see from Rutland to B, big boy, again, we have a negative there from Rutland to Big Boy. Again, this is a minimization problem. So for when we're checking for optimal, we have to make sure they're all greater than or equal to 0. And a negative 4 tells us that we're not there yet. So that would be the entering variable. So we have to have a leaving variable, just like the stepping stone method. We could see that the two cells we could pull from, either Rutland to Acorn or Concord to Big Boy, the smaller of those two is 56. So 56 would be the leaving. So now I'll just write it all out as an improved solution. Okay, here's our improved solution for the MADI method. You notice that it agrees exactly with what we did before, so we must be right. Now we go repeat. Step 6 is to repeat, go back to step 3. We'd have to check for an optimal and go forward from here.